We have Lorena Espaillat and Philipp Siedler, both from Zaha Hadid, who are going to be talking to us about designing the workplace in the age of algorithms and machine learning. Thank you.
Thank you very much for having us. Yes, so we work at Hadid Architects, as mentioned, and we are in a small team of specialists, a quite small team, and we are looking into analyzing buildings and users' behaviors. And we are at the moment called Analytics and Insights within Hadid.
Yeah, so we're both architects, so you might wonder kind of what brought us into this more, say, scientific direction. And, well, I personally focus within our team more in the impact of the built environment in people's behavior and more like the social and cultural implications of design. Whereas Philipp here, he focuses more on the computational side of things, data, algorithms, and tool development. So what actually brought us to work together was our passion for design analytics, and this all starts with data.
Right, and so one of the most powerful and profitable algorithms are recommender systems used by Amazon and Netflix. But have you ever wondered what would Netflix actually recommend to you if you haven't watched anything at all? Okay, maybe it would pick up your location, your age, or some data you don't want to know of. And then, right, what would actually be recommended? So in order to, for this to really work, you have to watch something, right? You have to at least peek into a trailer or whatever, right? So here's a selection of buildings designed by Hadid Architects, which you might know. But just like Netflix, information collects about all the movies and series they have on their platform, like the genre or release date or even very complex content-based data. We are also able to store or collect data about our buildings, like daylight, visibility, connectivity of the space within, which you then can use to make recommendations for future designs. The power of the recommendation relies on the number of movies watched, or in our case, buildings designed, very well picked up also in the last talk, I think. This information then aggregates, highlighting trends and patterns, and should be impossible to detect by just looking at a handful of projects only. In a sense, the more you design, the better the recommendation.
Yeah, but this type of algorithms, you can find them anywhere. Actually, you can find them from a football match in which they're used to optimize teamwork, to also like web page algorithms in which they're used to personalize the content. And even when you eat an apple, an algorithm has been put in place to ensure a healthy crop. But actually, where is all this precision and teamwork in personalization and in health for workplace? We all know that many organizations nowadays do collect data on workplaces. And as we all are familiar with, this is mainly focusing on the construction costs and the operation costs of the building, looking mostly at things like occupancy and running costs. And yes, these statistics is very common. Yeah, we all focus on this little 10% of the building cost, which is comprised by the construction and the operation. But actually what holds most of the value of an organization is its people, which is the 90%. And we start looking at this 90% by modeling and by simulating buildings' performance before and after they are built. We argue that the way to guarantee a successful workforce is by fostering collaboration, building transparency, and supporting well-being. But actually, how do we measure these things, and how do we get insights from them? First of all, when we talk about collaboration, one of our basic premises is that one of the main drivers for communication is physical proximity, and this has been further linked to collaborative behaviors in the workplace. MIT professor Thomas Allen discovered how communication drops very drastically when you move, when the distance increases between people. And actually, it pretty much drops to zero after you go beyond something like 20 meters, which is something like a 20-second walk.
Right, so let's look a bit more at the application of this. So how can we, apply this theory in our projects? So consider this typical center core building, such as this one. So how many people are in range of any of the desk locations? Part of the development we are doing is a tool that calculates the distance from every desk in the building to any other point. So measuring the distance to all coworkers on the floor enables us to calculate the connectivity as well as the potential ad hoc conversations. In this case, interestingly, the worst places were in the corners, normally reserved for managers or team leaders. We can also look at the analysis of different furniture types. Here we were looking into a more linear or more organic kind of typology, and we found out that using a more smooth or more less rigid furniture system would increase connectivity by 10%. We also looked at the core location itself and the effect that has on a connectivity. Just by softening the corners of the core, we could increase average connectivity by 5%. Whilst pushing the core to the edges will increase connectivity by 84%, which is unrealistic because we don't have daylight anymore. But putting a central atrium will decrease it by 19%. Also considering visibility, we have observed that people are much less likely to make a journey to someone they can't even see. And we can compare core configurations, making significant impact on visibility. This time, the smoothing of the core's edges enables people to see 6% more of the people on the floor plate. We can also look at how each space compares in terms of environmental qualities like daylight penetration. And again, compare our core configurations. Now the central atrium floor plate might have been medium for visibility, but it's excellent for the daylight penetration. We can now start to look at pros and cons of various options based on a range of parameters. This enables us to make informed decisions in the future. For example, in this tower competition, we are able to rapidly assess a variety of core configurations and building envelopes to support decision-making in the very early design stages. We also start to develop an algorithm that can generate every core location and analyze it against every other. The example I'm going to show is for a square tower with every core shape and location within a 50-meter grid for both a single and double core option, which is then analyzed for daylight and cross visibility. So at 1 option per second, it took 27 hours for it to generate, analyze, and compare all possible, something like 100,000 core options. Manually, if we would draw up and analyze, let's say, 40 diagrams a day or so, it would take about, 10 years or so, right? So after this decade of analysis, which would be the best?
Then that brings us to the point that actually we cannot just apply this to every project because in theory, yes, we could have done this in the past where organizations and their cultures were more like monocultures, like the picture on the left. But however, nowadays successful companies are more like polycultures. They are diverse, sustainable and resilient ecosystems like the image on the right. And they support and encourage multiple ways of working and being. And architecture and design needs to be able to accommodate and be part of the ecosystem and company culture. So we have started to look at our past projects and analyze them and benchmark them against each other to understand how exactly they support this workplace diversity, and also how all the things we've been measuring inform the design decisions, like this project, office project in China. So in this case, we can look at aspects like we discussed previously, like shortest path to office entrances, and actually are able to identify things like which areas are more likely to suit the most and the least mobile staff. And we can also consider the paths from one desk to another, which link co-workers between each other. And then we can highlight which areas best suit independent teams, which is more likely to be in the more segregated parts of the office, and then the interdependent teams, which could be located in the more central parts of the layout. Similarly, we can look at how close you are to the facilities, like breakout areas or coffee machines. And then that allows us also to determine the areas in the office which are most likely to encounter the least distraction and where are most likely to be the quieter zones in the layout. And that helps a lot to kind of strategize the placement of teams within the office. Then if you also consider how much of your surroundings you can see and how much you can also be seen from any given point of the layout, this helps to determine how exposed certain areas are to the public sight, and this again helps the planning process by identifying which zones can be used for more planned and confident meetings, which would be more like out of sight, and the zones that are more likely to suit more informal and unplanned meetings, more like in plain sight. Now for the actual desks, calculating the amount of daylight that penetrates the building allows to identify zones for different degrees of permanence. So the best lit parts of the floor plan are more likely to suit people that spend the most time at their desks, whereas the zones that have less access to daylight are better for short stay periods, or what we call touchdown zones. Lastly, we can also look at the desk orientation and how can it affect the views. There's actually no point having a great view if your desk is facing away from it, and we're also able to measure this. We can compare results like on this project to others and gain insight for projects we're looking at the moment, like the Sberbank headquarters in Russia. Or also an atrium tower we're building right now in China. And actually, this kind of analytics, what they do is give us a very good guide as to how a space should perform and how it will perform in the future.
So, but I mean, it's not enough to only look at the performance of the built space. We also need to understand how people actually use space and how they feel about the space they're in. So there are a bunch of IoT devices like sensors which allow us to look into workplace in more detail than ever. So we have deployed sensors in a series of environments, one of which was an exhibition held by 3 of our research groups, Code, VR, and ourselves, Analytics and Insights. In order to gain insights from the readings, effective data visualization becomes key. Here we are looking at 670 hours of occupancy sensor data about exhibition attendance patterns in 10 seconds. And we are able to quickly build up an understanding of occupancy patterns from the individual person exploring the exhibition in the bottom row, building upwards to aggregating of the visitor over time. Furthermore, of course, now some boring graphs. We can look at how the space was used over an average month, each color representing one of the exhibition spaces. Or as well, of course, of an average day, right? So in the morning and in the afternoon and the late evening, there are some sort of peaks and the most interest. As well, of course, also the overall popularity of the exhibitions. Right. So here are a couple of movement readings from another sensor project at our London studio, actually in the design office. On interaction levels in one of our, it's in one of our main breakout spaces, sort of the entrance area. And then we have a second environmental sensor reading setup, or experimental lab, in one of our design studios, actually, which is visualizing a 3-dimensional kind of landscape of temperature, light, air quality that can be easily understood by the building operators. So if there's a complaint that the air conditioning is not working or so, someone can actually look into that and confirm. And then this can be, of course, made available to the end user, to the actual people who work on the floor, such as temperature or daylight in lux, CO2 in ppm. And combined, those could be used for preferences. And then the app or whatever could then suggest what location might be most comfortable for them the next time they're coming up to the floor.
And in the same way, we can start to look at how to match teams more efficiently with individuals against each other because teams can no longer be planned in an office by simply taking an organizational chart such as this one. And this is because communication and collaboration networks are now highly complex, and both physical and also digital. And to help develop an algorithm that could handle this kind of complexity, one of our influences was an algorithm set up for a very complex task in life, which is planning a wedding dinner at the table, so that the wedding end up like this instead of like this.
So yeah, you were all laughing, but that's actually how it went. We just found a GitHub repository of a guy who did that kind of ad hoc, and we took it on board.
And at least the wedding is just a few hours, but actually in an office, you can be sitting next to the same people for months, and that can have a very, very big impact on your productivity and potentially your sanity as well. And yeah, on the flip side, sitting next to the right people can have a very positive impact on your productivity. And probably greater than anything else in the built environment. And yes, by correlating maybe simple answers to a few questions, we can start to uncover some critical adjacencies between the people in your organization that are based more than just job title. And this now is a genetic algorithm that works out the best placement for 19 people based on their top 5 sympathy adjacencies. And it's running for all of them. And if we now do this for everyone on the same floor, we can find quickly that the dimensions of the problem, they increase exponentially. And actually there's a name for this, it's called the NP hardness problem. And yeah, because actually what happens is that there are way too many combinations for the system to handle. But we've solved this by applying clustering and divide and conquering strategies.
So green in that case would be perfect, and the yellow is quite a good match. Yeah. So obviously it's not able to find the all green kind of solution. All right. So yeah, to kind of wrap this up, how does this all come together? What do we mean by self-learning, and what do we need it for? So we are striving to create a system which is integrating a multitude of parameters, the one we've presented earlier in the presentation, and influences which are able to recursively react to a new input, just like described in the last talk very, very nicely, and then learn over time, right? So we are starting to investigate this with a matrix of furniture typologies that could be interchangeable in their activity as well as their scale. And then you could constantly update furniture from a catalog of activities. Basically, self-adjusting in space, that's circle packing, that's how they, the algorithm behind how they actually kind of fit into the space and how they situate themselves next to each other without overlapping and these kind of things. Yes, so multiple diagrams or diagrammatic options could be generated virtually instantaneously, creating a more efficient and rigorous design process. This can then be designed further once the preferred option has been established, and design should not need to stop there then, I guess. After the workplace is occupied, design can continue, feedback can continue. The design could update itself based on new density requirements or mix of program or collaboration needs based on sensor and user analytics. The design could even suggest its own periodically update. All right, thank you. Yeah, thank you very much. If you're more interested. Yeah, we have a couple of.
Probably should have had a warning for epileptics in the building there. So that was amazing. Can I ask in the audience, does anyone monitor people in the building? Not the building itself, but monitor people in the building? So quite a few do. Are the sensors, does anyone have sensors that people have on them? No? Okay. Thank you very much. Does anyone have any questions at all?
It's a very valid comment. Our team is very young. We are 2 years around so far. Yeah.
Yeah, and I guess handling this kind of complexity is kind of the sort of thing we're try to look into, each time, taking the tools every time a bit further and trying to incorporate each time something, I guess, bigger, such as interfloor connectivity. That is definitely something crucial, and the kind of things we kind of are super interested in.
Also, I mean, we're very close to the application of this, so the client always has a big say and kind of gives direction. And a lot of clients actually respond really, really well to just a 2D floor plate, right? Even better to a three-dimensional than to a three-dimensional representation. But we've been looking into penalizing when you have to use the lift or walk the staircase or whatever to do these kind of things. We've kind of further in the future. I don't think we have evidence of, let's say, a cultural change, right?
Yeah, and I guess most of these things, I mean, when we deployed this kind of algorithms, sometimes it only reaches the purely theoretical part of it, and we kind of support it in social and spatial theory, but we have not yet, because since we say we're very young teams, we haven't had the opportunity to really implement this, but we've had some solid evidence that something of this sort can really aid and help this a company and an organization kind of better understand what are the relationships between its people and what are the things that you should be looking at, rather than just going by the book and saying these teams are supposed to be allocated in a particular way, because they don't have to really.
Yeah, I mean, as I said, I think the, let's say, cultural aspect of an organization is really a very, very, very hard topic. And I think we're really trying to come from a spatial kind of perspective. And I think it would I don't even know if it would be possible to do that, actually, or to be able to answer your question.
Yeah, but also I guess it's a tough one, but definitely when you have certain, particular aims on what you want to achieve with your organization in general, then you can influence, because that's what we're trying to do now. If we are on board since the beginning stages of a project, we are able to model the conditions that, the designers are proposing, and then we're like, no, look, because if you actually want to foster more collaboration, or for give an example, and we can impact the design in a very early stage, you can have an impact on the future outcome of the behavior of the people. Yeah.
Put your hands together and thank Lorena and Philipp. Thank you very much.